Okay, we are going to start a review video here that's going to walk you through a lot of the very important topics that you're going to see on your Chapter 2 test. Remember, we're going to do an in-class review, but I do want to make sure I give you some guidance to fall back on in case something didn't make sense or it did in class, and then when you start to review your notes, it's not making sense for you. This is what this video is actually for. So I'm going to go probably too quickly through this for you, but feel free to stop this, rewind any of these examples at any time, and shoot me a text message if something isn't making sense, even if you watched it several times. Let's clear this up before you take your test. I've typed on the screen a few things to kind of guide me through giving you these examples, and the first one is to talk about a proper fraction. Remember that a proper fraction means that the numerator is less than the denominator, and so these are some examples of proper fractions. Okay? Numerator, top number, is less or smaller than the bottom number, the denominator. An improper fraction is just the opposite of that. It means that the top number is larger than or the same as the denominator. So these are all examples of improper fractions. The 8 is bigger than the 5, so that means the numerator is bigger or greater than the denominator. The middle example is 6 over 6, and this equals 1 whole. 1 whole is considered an improper fraction as well. All right, a mixed number. Remember, a mixed number has a whole number as well as a fraction included with it. And so these are all considered mixed numbers here. I want you to see that the fraction that goes with it is actually a proper fraction. It would be an incorrect mixed number if you had a whole number and then an improper fraction with it, because this could be simplified and added another whole to it if we needed to. So all mixed numbers will be a whole number and then a proper fraction along with it. All right, this next example, I have an image here that I'm going to break it down 1, 2, 3, 4 into 4 little lines. 2, 3. Okay, just pretend that these are all perfectly straight. I'll see if I can move them around a little bit and make it better. Yeah, close enough, right? We'll just pretend. All right, so I split this into 5 sections, and I'm going to shade a couple of them, and I want to talk about some fractions, and I'm going to ask you 2 questions about this. And did I shade them separately and not touching on purpose? Yes, I did. All right, so I'm asking you 2 questions. What's the fraction for the shaded portion, and what is a fraction for the unshaded? Well, we know that the shaded is the red, and so we're going to count 1, 2 shaded pieces, right? The unshaded we're going to call the blue now, and we're going to count 1, 2, 3 pieces. Well, what's our denominator? Our denominator will be the same for both of these because we're talking about a whole as our denominator. And so our whole denominator is going to actually have 1, 2, 3, 4, 5 pieces. And so they both are out of 5 pieces. We just talked about the red. We have 1, 2. And so 2 fifths are shaded. And how many are unshaded? Well, we said 1, 2, 3. And so depending on what the question asks us, we may end up with either a 2/5 answer for the shaded. If it asks us about the unshaded, we'd end up with a 3/5. All right, let me split these into pieces here, and we're going to pretend like my drawing is perfect and everything is beautiful. And I'm going to shade these a little bit. Okay, we're assuming that 1 full circle is a representative of the whole, okay? And so I would like to know, in a mixed number, what portion is shaded. So I need shaded, and I need a mixed number. Remember, mixed numbers are whole numbers and fractions, so how many wholes do I have? I have 1, 2, and 3. Remember, we're talking about shaded. Those are all 3 shaded completely, so that's where I got my 3 from. The fraction is going to come from this piece over here. The denominator tells me how many pieces there are, 1, 2, 3, 4. It doesn't matter if they're shaded or not. We're talking about the whole piece. How many are in the whole? That's what the denominator is. And then how many of them are shaded? Well, we know that there's only 1 shaded, and so my final answer for this is 3 1/4. Final answer. Okay. We're going to do a little multiplication. We are going to multiply 3 times 3/4. Okay, we know that this 3 is an understood 3 over 1 as a fraction. This is multiplication, so I'm going to simplify in the diagonals where I can and then multiply straight across the top and straight across the bottom. And so I end up with 9/4. 9/4 is an improper fraction. If the instructions tell you to change it to a mixed number or a proper fraction, you would need to divide this. So we would need to be 9 divided by 4 is 2 with 1 left over. So 2 1/4 would be my final answer for this. Okay. The next problem is to change it from a mixed number to an improper fraction. Okay, remember that this method is a backwards C format. Okay, so we would take 3 times 4 and then you add that extra number up there, so plus 2. So 3 times 4 is 12. 12 plus 2 gives me 14. So this is 14 is my top number. The bottom number stays the same. And so 14/3 is the mixed number 4 2/3 changed to an improper fraction. It's improper because the numerator is bigger than the denominator. We're going to change this improper fraction to a mixed number. So if we have this, remember this represents a division problem, right? So we would take this top to bottom is how we read. And so we would take 18 divided by 4, and you would find that 18 divided by 4 is not a perfect number, right? But it does go 4 times. 4 times 4 is 16. I subtract and I end up with a remainder of 2. So this guy's my numerator. So this guy's my whole number. So 4, 2 is my numerator, and the already existing denominator stays the same. All right, I want you to see one more thing, that this 2/4 is actually a fraction that can be simplified. They both can be divided by 2. And so 4 1/2 is actually my official answer for this. All right, the next one is going to be a mixed number subtraction problem. So I've got 8 1/9 minus 7 8/9. All right, this is a common denominator problem. It already has one, so you don't have to find one. But I know that I'm going to have to borrow. So for those of you that like to borrow, and you can do this set up vertically, this is how you will do it. You will take 8 1/9 and set up 7 8/9. We're going to treat this like 2 separate problems. Unless I have to borrow, then I'll move into other territory. So I have 1/9 minus 8/9. I know that I can't take 8 away from 1, so I know that this is not going to work and that I actually am going to have to borrow over here. And I'm going to mark out this 8 and it's going to become a 7. If I borrow a whole and I already have this, it's going to be added to it, okay? So a whole would be 9/9. 9/9 is 1 whole, and this 1 whole right here added to 7 is how this 8 right here was existing. And so I actually have to add these two together for this problem to move forward, okay? And so I'm adding 9 1/9 plus 9/9. This gives me 10/9. It's okay that it's an improper fraction right now. I'm just going to be using it for a subtraction problem. So this whole piece right here became this guy right here, okay? So I'm going to kind of mark this out and get rid of it and just put that piece in so it looks a little prettier. So all this work became 10/9. So now I have 10/9 and 8/9. And it's a subtraction problem. So here is my 10/9 minus my 8/9. The denominators match, so I bring it straight over. And I'm going to subtract 10 minus 8, and I get 2. So this whole piece comes down to be 2/9. Over here on this side, I've got 7 minus 7, which is 0. And I don't really need the 0. It just means nothing. So after I subtract those two fractions, I end up with a final answer of 2/9. Okay, we're going to use these same exact numbers, and instead of it being a subtraction problem, we're going to do this again using an addition problem. So I have 8 1/9 plus, 7 8/9. All right, so if I add things together, I don't have to borrow, so I'm just going to go ahead and set this up vertically. I have 8 1/9, and I have 7 8/9. I'm going to add. Remember, I'm going to box them off here so you can see one side and then the other side. So I'm going to take these two right here, and I have 1/9, and I'm going to add it to 8/9. The denominators are the same, so I'm going to add the numerators, and I end up with 9/9. Well, 9 over 9 is the same thing as 1 whole, right? Remember, you could divide this, 9 divided by 9, because that's what this is, a division problem, and it gives you 1. So this became a 1 whole, which is actually going to need to be added to this whole column, because I don't need any fractions anymore. And so there's actually nothing coming out of this side, but there's only going to be an answer over here. And so I have 8 plus 1 is 9. 9 plus 7 gives me 16. And so 16, whole number, is my final answer. Okay, we're going to work on a problem where, well, we just borrowed. Let's see, which one do I have here? We're going to give you an image, a picture, and we're going to draw some measurements or lengths on here. Okay, and it asks you to find the perimeter. And so the perimeter, remember, is all of the sides, 1, 2, 3, and 4. So 4 measurements added together. So I don't know what the measurements of these other pieces are, except for I really do. It's just going to be the same measurement that you see across from it, just duplicated, okay? Because we know it's a perfect rectangle. Or we're going to pretend like my picture really is a perfect rectangle. So I'm going to add these measurements. I have 3/10 plus 3/10 plus 9/10 plus 9/10. And so I'm going to add all these together, and I end up with 9 plus 9 is 18, and then plus 9. And so this is going to give me a denominator of 10, right? Because it's the same. I'm going to bring it straight over, and a numerator of 27, I believe. And so when I end up with this 27, 9 and 9 is 18, 19, 20, 21, 22, 23, 24. 24, I should make sure I can add. That'd be great. So 24 is my numerator over 10. All right, so 2 things that I can do. First of all, I'm going to take my 24 over 10, and I'd like to simplify. And I'm going to do that by dividing by 2 on the top and bottom. We always simplify by dividing by the same number on top and bottom. And so I get 12/5. Now that it's simple and a smaller fraction, I can actually divide it and find out what my answer is going to be. And so I need a mixed number, so I take 12 divided by 5, goes 2 times with 2 left over. So my whole number is 2, my remainder is my numerator, and the already existing denominator is also my denominator. So 2 2/5 is this perimeter measurement added all up, okay? All right. Make sure we're covering all of the things we need to. Let's make sure we can multiply and simplify in the diagonals. All right, it's a multiplication problem. I am going to simplify in this diagonal by dividing by 3 on both sides, and so this becomes 1 and 4. When I multiply straight across the top and straight across the bottom, I get 8/5. I need this to be a mixed number or a proper fraction, and so when I do this, I end up with 1 and 3/5. Final answer. Okay, we're going to do a division problem. All right, so the rules for dividing are keep it the same, change it to multiply, and flip it over. So we're going to divide, and we're going to just treat this like multiplication now. So this became 1, this also became 1, multiply across the top, multiply across the bottom, and I get 2/5. Okay. We're going to find the area of the rectangle that I'm giving you here. The measurements are 1 and 1/2 and 2 and 3/4. If I'm going to find the area, remember the area is length times width is how you find area, okay? And so length times width, the length is usually the longer side, the width is kind of the shorter side, and so we're going to multiply the long side times the short side. For us to do this, we need to make sure that we change these into improper fractions by using that C method, the backwards C method. Same thing on both sides here. And once we get these to the improper fraction stage, then we can actually simplify where we can and then multiply across the top and bottom, and then we'll be done. So this is 4 times 2 plus 3, right? 4 times 2 plus this 3 on top. 2 times 1 plus 1. And so 4 times 2 is 8. 8 plus 3 is 11. And I keep the denominator I had. Over here, the same thing. 2 times 1 is 2 plus 1 is 3. And I keep the denominator that I had. And it's 2. So here I'm going to simplify where I can, and it doesn't look like I can at all. And so I end up with 33 over 8. 33 over 8 is an improper fraction. If it says that you can leave it as an improper fraction, this would be great. If it does not and asks for a mixed number or a proper fraction, you would need to divide to simplify this. Remember, this is the top number divided by the bottom number here is what we're looking at, okay, this piece. We're going to work it out long ways here. And it looks like 8 goes into 33 4 times, which is actually 32. When I subtract, I only get 1 left over. So this guy is my whole number up here, okay? This guy is my numerator remainder, right? And then the denominator that I did have is still my denominator. So 4 1/8 is my final answer for this one. All right, we're going to do a little order of operations here, and then we will be wrapping up this chapter. We're going to start with comparing fractions. Okay, I've got 2/3 compared to 3/4. They do not have a common denominator, so we're going to multiply in the diagonals and compare our numbers. So 3 times 3 is 9, and 4 times 2 is 8. 9 is bigger than 8, and so less than symbol is my answer. Remember, I'm choosing this symbol because this mouth has to eat the bigger number. It has to face whatever number is the bigger number. Okay, let's try another one. I've got 3/8 compared to 1/4. The denominators, these are what I'm talking about. The denominators do not match. Since they do not match, I need to use this cross product rule to figure it out. I multiply 8 times 1 and I get 8. Multiply from bottom to top over here and I get 12. And what I want you to know is that if you mix these numbers up, you will get the wrong answer. But you go from bottom to top, and whichever side you end up on the top is where your number stays. And so the other side is 12, so 8 and 12 compared, the mouth needs to eat the 12, and that's your final answer. If you go from top to bottom and you wrote 8 over here on this side, you would end up with a wrong answer here because it would flip your symbol to the other side. So you go from bottom to top every single time. Okay, let's do one more of those, and then let's try some order of operations. All right, so I'm comparing. The denominators do not match, so I'm going to multiply from bottom to top and from bottom to top, and I find that I found 9 and 9, and they are the same. So equal is actually my answer for this one. All right, let's do a order of operations problem. All right, a little bit confusing, but we're going to talk through it. Parentheses. I have 2 of them, but I can't do anything inside these parentheses. Okay, they are division problems, but it's going to turn me into a decimal rather than leaving them as fractions, and I don't want to do that. So I'm going to move through that, and I'm going to start back at this exponent. And here's my exponent portion. That means I'm going to bring this guy down and just leave it alone, but this is the piece I'm going to solve. And so my base is 1/2. And so 1/2 is what I have, and I have it 2 times because my exponent tells me so. So this is what I'm solving. 1/2 times 1/2, multiply across the top and get 1, across the bottom and get 4. And so if I'm bringing down that 1/2 over here, it's now multiplied times this 1/4, which is the answer of this portion right here. 1/2 times 1/4 cannot simplify in any of the diagonals, so I multiply across the top and across the bottom, and this is my final answer. Okay, I've got one more problem that I am going to work as a fraction order of operations. Okay, so this is a very similar problem. It's just a little bit bigger numbers. I've got 1/2 times 2/3 squared. So parentheses, I don't really have anything going on, but this exponent piece needs to happen first. I do know that this piece is going to be brought down. So I have 2/3, which is my base, times itself twice, right? I see 2 of them because of that squared up there. Multiply across the top and across the bottom. Please do not put 4/6 here, it's 4/9. Okay, so this whole piece became 4/9. I have not used the 1/2, and that's what I'm bringing down right here. I'm going to simplify where I can, and I'm going to divide the denominator and the numerator here in this diagonal both by 2, and I find 1 and 2 here. Multiply across the top, and I get 2, across the bottom, and I get 9. So 2/9 would be my final answer for that one. All right, so that's all I have for a review for Chapter 2. If you have any questions, please send me a text message, and I will make sure I answer them for you.